Welcome to The Explainer. Today, we are cracking the code, the secret language that powers literally every single digital device you own. We're going to learn how machines talk.
Okay, let's start with a little puzzle. You and I, we've got 10 fingers. It's how we've learned to count for thousands of years. But a computer, well, it doesn't have any fingers. So how in the world does it count?
And the answer is, well, it's pretty simple actually. We're speaking two totally different languages. Our language is based on 10 symbols, because of our 10 fingers. A computer's language is based on just two states, on and off.
So let's get into this tale of two languages. And to really get it, we first have to ask a more basic question. What even is a number system?
A number system is really just a set of rules and symbols for representing amounts. You can think of it like a dialect that's specifically for counting. It's got its own alphabet and its own grammar.
So you've got our dialect, right? Decimal. It's got a vocabulary of 10 symbols, 0, 1, 2, all the way up to 9. But the machine, its dialect, binary, has a vocabulary of just 2, 0 and 1. That's the whole shebang.
Okay, so let's look at the rules of 10. To get a feel for the machine's language, we actually have to take a closer look at our own, the one we use every day without even thinking.
I mean, you've been doing this your whole life, right? Counting? But have you ever really stopped to think about the rule, the one that tells you what comes after 9? When you run out of symbols, what do?
It's this super simple idea we can call the odometer rule, like in your car. When that first dial hits its highest number, 9, what happens? It resets itself back to 0, and click, it bumps the number to its left up by 1. And that's how we get from 9 to 10, 10.
Now for the really cool part, the power of 2. Because that same exact rule, that odometer rule, is the key. It's the bridge that lets us cross over into the computer's world.
Because, when you get right down to it, a computer is just a bunch of light switches. It only knows two things, off, which it calls a 0, and on, which it calls a 1. Everything, and I mean everything, from your games to your emails, is built on that one simple idea.
All right, so let's try it. Let's put that rule to the test. If a computer only has 0 and 1 to work with, how on earth does it count to the number that we call 2? What comes after 1?
And this is where it all clicks. We follow the exact same steps. We count 0, 1, we've hit the highest symbol in this new alphabet. So what do? We use the odometer rule. We reset the current digit to 0, and we increment the neighbor to the left. Boom. The number we call 2 becomes 10 in binary.
And get this isn't just for binary or decimal. This is the golden rule for any number system. It doesn't matter if you have 2 symbols or 16 or 100. When you run out of symbols, you just flip back to 0 and carry one over to the left. That's it. That's the engine that drives all of this.
Okay, final section. Let's really learn how to speak this language. Now that we know the rules, we can actually start translating from machine speak back into human. So let's say a computer flashes this number at you, 1101. It looks like total gibberish, right? But it's not. It's a perfectly good number. So what is it actually saying to us?
So how do we translate this thing? Well, there's a really simple trick. Let's forget all the complex math for a second and think about something we all understand, counting cash.
Okay, check this out. Just imagine that each spot in that binary number has a set value, kind of like a dollar bill. Starting from the right, you have the 1's place, the 2's place, the 4's place, the 8's place. You see how it just keeps doubling? The binary digit, that 0 or 1, is just a simple yes or no. Do you have that bill or not?
So, for our number 1101, let's look at our cash. Do we have an $8 bill? Yes, we have a 1. A 4? Yep. A 2? Nope, that's a 0. A 1? Yes. So you just add up what you have. 8 plus 4 plus 1 equals 13. Simple as that. The computer was just saying 13.
And really, that's the whole secret. The entire digital world, all the crazy video games, all the complex science, everything on your phone. It's all built from this ridiculously simple language of on and off, just scaled up millions and millions of times.
It's an amazing idea, isn't it? And it kind of makes you wonder, what else in our world looks incredibly complex on the surface, but is really just a set of very simple rules repeated over and over and over again?